Good morning, all of you. Yesterday, we saw some characteristic properties of acids. First one, acids are sour in taste. Second, with indicators, acid shows its presence. For example, acids can turn blue litmus red. Bases can turn red litmus blue. We tried with in other indicators, phenolphthalein, methyl orange, etc. Now, we are going to see the chemical properties of acid. Acid can react with metal, or metal plus acid gives salt and hydrogen. Highly reactive metals react with acids to form salt and hydrogen. Let's see the experimental setup for this. Here is the experimental setup. Zinc. This is our acid, this is the metal. Zinc metal is reacted with this acid. You can take HCl, hydrochloric acid, instead of this H2SO4. So acid reacts with metal to form salt and hydrogen. What is the salt here? Zinc sulfate. Means zinc replaces this hydrogen. Zinc replaces this hydrogen from this acid. See, hydrogen is coming out. You can show this arrow mark here. So zinc is taken in this test tube and zinc granules, small pieces. Zinc granules means small zinc pieces are taken and sulfuric acid, dilute sulfuric acid or dilute hydrochloric acid is added through this. And through this delivery tube, hydrogen gas is coming out and it is passed through soap solution. We know that when we blow through a soap film, that bubble will be covered with a film of soap solution. Similarly, here hydrogen gas which is bubbled through the soap solution will be coming out as globules. Means the gas will be trapped inside this. Means gas will be covered with a thin film of soap solution. So you'll be getting globules here, bubbles here. How to check the presence of H2 hydrogen gas? You bring a lighted candle to this, hydrogen will burn with a pop sound. That means you can make sure that the coming gas is hydrogen gas. So metal plus acid, we are learning the properties of acid. Acids can react with metal to form salt. This is the salt and the other one is hydrogen. Now you see, repeat this activity with some more acids like HCl. With HCl you will be getting hydrogen gas. But with HNO3, if it is very dilute HNO3, these are the products obtained. In addition to the salt. In addition to the salt, I will be writing the salt over here, zinc nitrate. You will be getting ammonium nitrate and water. So such big equations are not there for you. Or if it is warm and dilute HNO3, again you will be getting salt and N2O and H2O. So this also you don't learn. So with HNO3, you will not get hydrogen gas. But with CH3COOH, you will be getting hydrogen gas. That is acetic acid. CH3COOH is acetic acid. We call it as vinegar. Vinegar on reaction with zinc metal, you will be getting CH3 CH3COO twice Zn. If it is an organic acid, you have to first write that organic portion. So this is acetic acid and this is zinc. So this is called zinc acetate. This is called zinc acetate and hydrogen gas will be produced. So from here you have to learn this HCl, CH3COOH and this H2SO4 dilute sulfuric acid. So generally we can say metal plus acid gives salt and hydrogen. Now what happens with metal plus base? If you, instead of this acid, if you are putting one base, metal plus base, metal plus base is NaOH. NaOH. So this is zinc solid NaOH is aqueous solution, means NaOH pellets mixed with water to form an aqueous solution. It will give this salt, that is Na2ZnO2. Na2ZnO2, that is the salt formed, plus hydrogen gas. Hydrogen gas. So in the case of base also you see the production of hydrogen gas. However, such reactions are not possible with all metals. Only with few metals you will be getting this reaction, that is base plus metal. Metal plus acid gives salt and hydrogen. Metal plus base also gives salt and hydrogen. So that is one characteristic property of acid. Acid on reaction with metal gives salt and hydrogen. Now another property, that is of base. Base on reaction with metal gives salt and hydrogen. So I am writing these two things here. Metal plus acid. Metal plus acid gives salt and hydrogen. Hydrogen, or metal plus base. Metal plus base gives salt and hydrogen. So acid property, it is sour in taste, it turns blue litmus red. Base property, it is bitter in taste, soapy to touch. With a red litmus, means bases change red litmus to blue. Another property of acid. Another property of acid, that is how do metal carbonates and metal hydrogen carbonates react with acids. So we are again coming back to acids. How do these acids react with number one, metal carbonate? Metal carbonate, and number two, with metal hydrogen carbonate. Metal hydrogen carbonate. Metal carbonate, for example, Na2CO3. Metallic portion is this. This is carbonate portion. Metallic portion, this is carbonate portion. So metal carbonate, Na2CO3 plus. I can take HCl. This is acid. So we are treating with our acid. What we are getting is salt, that is NaCl, salt, water plus carbon dioxide. So this is a general formula. So metal carbonate, or simply you can say carbonate. Carbonates react with acid to form salt, water, and carbon dioxide. Now Na2, let me balance this equation. Na2, there is here only one Na is seen, so I'll be writing a 2 in front. Only the beginning numbers are to be changed. While balancing, only the beginning numbers are to be changed, not these down numbers. These down numbers should not be changed, these down numbers should not be touched. Only the beginning number here, 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 these can be changed. So now you see here 2Cl, this 2 is common for these both. 2 is common, 2 is for Na, 2 is for Cl also. So there are 2 Cl. So I'll be writing 1 2 here. I should not write in between, only in the beginning I have to write. So I'll be writing a 2 over here. Is it balanced? Now once again you check Na2 to Na. 1 carbon, 1 carbon. 3 oxygens, 3 oxygen, 1 plus 2, 3 oxygen, 2 hydrogens, 2 hydrogens, 2 Cl, 2 Cl. So equation is balanced. The equation is balanced. Now let's see the reaction with metal hydrogen carbonate or bicarbonate. For that I am taking the example NaHCO3. NaHCO3 plus HCl gives again salt, water, and carbon dioxide. This is bicarbonate, or you can call it as hydrogen carbonate. Hydrogen carbonate. Bicarbonate plus HCl or hydrogen carbonate plus HCl again will give you salt, water, and carbon dioxide. This is salt, water, and carbon dioxide. Now in both the cases you are getting carbon dioxide as the gas. Carbon dioxide means one gas is coming out, some brisk efflorescence you are seeing, brisk efflorescence of carbon dioxide, brisk effervescence. Brisk effervescence is just like what you can say when you open a Pepsi bottle or a Coca-Cola bottle or a soda bottle, the gas rushes out, giving the drink a sparkle. So, to give an appeal to the drink, they had already put that carbon dioxide dissolved in that water. So, this brisk effervescence means the rushing of gas. The rushing out of gas is called brisk effervescence. Which gas is rushing out? Carbon dioxide gas is rushing out. How can you check the presence of this carbon dioxide or the coming gas is carbon dioxide or not? For that, the coming gas is passed through lime water. Lime water is CaOH twice. You can pass the gas through lime water. If the lime water turns milky, milkiness is due to the formation of that solid calcium carbonate. Let me write that equation. If I pass that carbon dioxide gas through lime water, that is CO2 plus CaOH twice. This is lime water. Lime water, aqueous solution. Lime water is CaOH twice. So when I pass this carbon dioxide through lime water, what happens? Calcium carbonate is formed. Calcium carbonate solid. That is calcium carbonate means chalk. So this calcium carbonate, it comes as a white precipitate. White precipitate. That's why that milkiness appears. Milkiness, or it becomes milky, plus H2O liquid. So what you are seeing, a milky solution. If the solution turns milky, if lime water turns milky, then you can say that the passed gas is carbon dioxide. If you pass this carbon dioxide for longer time, then the milkiness disappears. That is due to the formation of calcium hydrogen carbonate. If you pass this carbon dioxide for longer time, what will happen? This milkiness or disappears. That means when you pass excess carbon dioxide, so this is the thing in the test tube. This is the thing in the test tube. To this, we are passing excess carbon dioxide. So I'll be showing that equation. That is, carbon dioxide gas is passed, means on passing excess carbon dioxide through what? That CaCO3 solid plus H2O liquid. To that I am passing again carbon dioxide. Then what is happening? Calcium hydrogen carbonate will be formed, CaHCO3 twice. This is in the aqueous format. This is soluble in water. That's why you are not seeing any milky color, no precipitate. Soluble in water. So this calcium bicarbonate, since it is soluble in water, you will not see any milky color. But calcium carbonate is a precipitate that was insoluble in water. So milkiness is due to the formation of insoluble calcium carbonate as a precipitate. Insoluble means precipitate. But here, calcium hydrogen carbonate, what is formed, is soluble in water. That's why the milkiness disappears. Let's see the experimental setup for that. You see a test tube in which sodium carbonate is taken. To that, we are passing dilute hydrochloric acid through this thistle funnel. Thistle funnel is a glass tube with a mouth like this. A glass tube with a mouth like this. So, through this, we are passing. It's a long tube. So, through this, we are putting what? This dilute hydrochloric acid, and the tube is reaching till this, means it is immersed in this, see this thistle funnel, it is immersed through this aqueous solution. Otherwise what will happen, the carbon dioxide gas will be formed, will the carbon dioxide gas that is formed will be entering through this. Since it is dipped in the solution, the gas will not enter through this. Gas will be entering through this thing only, this delivery tube. So the thistle funnel's end should be dipping in the solution. Otherwise, the carbon dioxide gas produced will be entering through this, and you will see bubbling in this. So there is a wastage of carbon dioxide gas. So the thistle funnel's end is touching this aqueous solution. Now sodium carbonate that is Na2CO3 and here dilute HCl. So Na2CO3 plus dilute HCl, that is HCl, gives salt. Salt will be present in the soluble form in the test tube itself. Salt, water will also be present in the test tube only. Carbon dioxide gas, since it is a gas, it can rise up and it will be going passing through this delivery tube. It will be passing through this delivery tube and this gas, it will be passing and passing, and in this test tube we have taken this lime water. This is lime water. It is a transparent solution. Aqueous solution means made in water. So this carbon dioxide will be passing through this carbon dioxide will be passing through the solution. You will see milkiness over here, means white precipitate of calcium carbonate is formed here. We have taken this lime water. That is calcium hydroxide solution. To that we are passing this carbon dioxide gas. This lime water turns milky. That is due to the formation of calcium carbonate. But if you are passing this carbon dioxide for longer time, means if you are passing this carbon dioxide excess carbon dioxide if passed, then this calcium carbonate will change to calcium bicarbonate. Calcium bicarbonate, CaHCO3 whole twice. This is soluble. Calcium bicarbonate is soluble. So we see the milkiness disappears. So here we have taken metallic carbonate. Sodium is metal. Its compound metallic carbonate. If you are taking bicarbonate, same is the reaction. Carbon dioxide will be produced. So sodium carbonate, whether it is sodium carbonate or sodium bicarbonate, that is sodium hydrogen carbonate, the produced gas will be carbon dioxide only. So carbon dioxide when passed through lime water, milkiness appears due to the formation of insoluble calcium carbonate. If excess of carbon dioxide is passed, that means for a longer time if you are passing this carbon dioxide, the milkiness disappears due to the formation of soluble calcium bicarbonate or calcium hydrogen carbonate. So this is the property of an acid. First property we learn, acids are sour in taste. Acids turn blue litmus red. Acids react with metal to form salt and hydrogen. Acids react with carbonates to form salt, water, carbon dioxide. Again, acids react with bicarbonates or bicarbonates or hydrogen carbonates to form again salt, water, and carbon dioxide. Presence of carbon dioxide can be detected by passing through lime water. If it turns milky, that means the produced gas is carbon dioxide. So, what are the characteristics of acids? First one, acids are sour in taste. Number two, acids turn blue litmus to red. Acids turn blue litmus to red. Number 3, acids react with metals to form salt and hydrogen. Number 4, acids react with carbonates, means metallic carbonates to form salt, water, and carbon dioxide. Number 5, acids react with hydrogen carbonates. Hydrogen carbonates to form again salt, water, and carbon dioxide. So acids are sour in taste. Acids turn blue litmus to red. Acids turn blue litmus to red. Acids react with metals to form salt and hydrogen. Acids react with carbonates to form salt, water, and carbon dioxide. Again, acids react with hydrogen carbonates or bicarbonates to form salt, water, and carbon dioxide. Next property is acids contain H plus ions. All acids. When you check the formula HCl, see H is there, H2SO4, H is there, HNO3, H is there, CH3COOH, acetic acid or vinegar. This is acetic acid. See, H is there. So, all acids are having what is common? All acids are having H plus ions. H plus ions. And these acids can produce these H plus ions in presence of water. Means on adding water only. On adding water only. On adding water, they can produce H plus ions. So acids have H plus ions in common. Since we are adding water to form this H plus ions, these H plus ions formed will be combining with this H2O to form H3O plus. We call it as hydronium ion. Hydronium ion. So every acid is having what is common in it? H plus ions. These H plus ions are produced on addition of water to that. We'll be seeing that with an experiment. These H plus ions, since we are adding water, this H plus ions will be getting attached to this water, will be reacting with this water to form hydronium ion, H3O plus. So this is another characteristic property of acid. So we have seen many characteristic properties of acids. Similarly for bases also, bases are bitter in taste, they are soapy to touch, they have OH minus ion in common. Generally OH minus ion, NaOH, KOH, base. then calcium hydroxide base, MgOH twice base. So bases are having OH minus ion in common. Bases are bitter in taste, they are soapy to touch, they have OH minus ion in common. Then bases also react with metal to form salt and hydrogen. These are the general characteristics of bases. Next, we'll be learning reaction of acids with metallic oxide. Metallic oxide, for example, Na2O. Metallic oxide. Metallic oxides are basic in nature. Metallic oxides are basic in nature. And non-metallic oxides, for example, carbon dioxide, they are acidic in nature. They are acidic in nature. Means on reaction with water, this basic oxides produce bases. See Na2O, this is basic oxide. Na2O on reaction with water, you get base, NaOH. This is base. Similarly, acidic oxide, that is acidic oxide, carbon dioxide, non-metallic oxide. This is metallic oxide, this is metallic oxide, this is metal, this is metallic part, this is non-metallic part, carbon is non-metal. So this is non-metallic part. Non-metallic oxides are acidic, means when non-metallic oxide is reacted with water, we get acid. H2CO3. So this is an acid and this is a base. Acid can react with base, or we can say base can react with an acid to form salt and water. To form salt and water. So you can take another base NaOH plus acid HCl to form salt and water. So this is a property of both acid and base. So acid can react with base, or we can say base can react with acid to form salt and water. Salt and water. I'm stopping here. Thank you.